Hello everyone, my name is Arthur. Today I'd like to share with you my project, TOTP for PSP. So this is my first time doing PSP Homebrew, and I'd like to thank the organizers of this conference for inviting me to showcase my project. So let's begin. TOTP, short for time-based one-time password. Nowadays, basically any online platform has this as a security measure. Having to enter a 6 digits code to log into your bank, social media, etc. What does the PSP have to do with it? Well, first let's look at the options and weigh the pros and the cons first. Most popular option is getting this code via SMS or phone call. It's the most convenient, but it's shown to be vulnerable to things like SIM swapping attacks, where essentially the bad guys can contact your telecom provider and pretend that you changed your phone number. And using that new phone number, they will intercept your OTP code. The second option here is using a dedicated app like Google Authenticator, where you can simply copy and paste this code to log into your website. The problem with this is there are known cases with clipboard hijackers that steal your clipboard contents, but same goes for your OTP code. And when these apps back up to the cloud, like Google Authenticator does, you should be even more skeptical. So some researchers did a write-up and found Google Authenticator to send the user's keys in plain text, which is a huge fail. So up until now, you see the theme where security is traded off for convenience, which is ironic because these OTP devices are supposed to add a layer of security. For a third option, we have offline dedicated hardware. You don't trust any online platform to store your keys. Originally, there were these coined battery fobs that displayed a code each time you pressed a button, and it would show you one code at a time. These existed in a time before smartphones, devices were not always online and connected. You had iPods for music, PSPs for gaming, and your phone for texting. So fast forward today, I decided to repurpose the PSP's hardware to generate these codes offline as a backup method in case you lose your phone and if you don't want to use any online platforms. Well, how do you go about generating a TOTP code? According to RFC 6238, this is a document that serves as a guideline for implementing the algorithm. It's essentially a function that takes in two things. So first we have a secret key string and an integer timestamp, that is the current time in seconds divided by 30. I won't go into the details how this hash function works since I wanted to showcase more about the PSP's hardware, but I'll try to explain at a high level how these two things are used. So initially at time 0, let's say we have a user Alice. She wants to set up an account to log in at a bank. Both Alice and the bank server agree on this secret key, which is a string of characters. Let's just assume only Alice and the bank knows the secret key initially. They might use RSA or another key exchange method, but that's not important for now. Then at time t1, Alice wants to withdraw from the bank. She first takes the secret key, k, and the current timestamp t1, then computes this function to get the 6-digit code 123456. She sends this TOTP code along with the request to the bank, and the bank performs the same calculation. Usually T1 is a window like 30 seconds. When the bank verifies that Alice's code matches its own computation using the same key that was set up initially, then the request is granted. Alice gets her money in this case. But let's say in step 2 here, someone called Eve was eavesdropping and managed to get a hold of this code 123456. Now at time t2, Eve tries to impersonate Alice using the code 123456, which she stole from time t1. The bank will compute with Alice's key and a present timestamp t2, and it finds that it does not match the request. So it rejects the request. The smaller this time window is, the less likely attackers can successfully get access by guessing or replaying these codes. You need an accurate clock to perform this calculation. Okay, so now we need a couple things to get this working on the PSP. First, we obviously need to store the secret keys someplace. You can export these keys from Google Authenticator via a QR code, and it will give you one Authenticator entry per line. I chose to store them in a file on the memory stick, MS0, under this path. Then you can read this file line by line using fgets, which is a pretty standard way in C. Now, a more secure way is probably writing this file to the PSP's internal flash memory, which has a few unused partitions. I didn't know these partitions existed before, but I was too afraid to write to the flash in case I bricked my one and only PSP. Next, we need some buttons for navigation, things like scrolling a long list of OTP codes. This is straightforward with the PSP SDK. Reminds me a bit of Curse's programming, right? Except you don't have to memorize the ASCII codes to get a key press from the keyboard. It's all defined here. I haven't tried other UI libraries, so I went with the most straightforward way for now. So next, the OTP function itself, the hash function, which takes in the key and the current timestamp. I just found a C implementation off of GitHub. Again, not going to go into the details about how the hash works, but I recommend you read the RFC because it explains every step and it provides a list of test vectors, of which I found very useful to help me test and get my C implementation working. So far, we can read and store the keys, but what about the timestamp? How do we get that integer timestamp? So the PSP has an internal hardware clock, like most embedded devices, but here's where things started to get weird in relation to the hardware. Most C programmers probably are just going to use the time.h header and call time null to initialize it and get the epoch timestamp, you know, the number of seconds since 1970, January 1st. On the PPSSPP emulator, which I use here at the top of the screenshot, it seems to work fine, but on the real hardware, I get a different value. You can see this value is much smaller in the first row. And flipping through the documentation, I found another function called sce kernel libc time. So this time, it worked consistently on both emulator and the real hardware. So I ended up using this one. And as for the screen, to display things, we obviously need fonts. I used a pretty old library called Intrafont from 2009, someone by the name of Ben-Hur. What I didn't know was that the emulator actually ships with a different set of font files than what's on the PSP hardware. This is due to copyright reasons, since the font files are Sony's intellectual property. So as a result, I could only use certain fonts that were common between the emulator and the PSP. And to get the original fonts, you need to essentially dump them from the PSP's flash memory. Those flash partitions, which I mentioned previously. In the end, I ended up using the system font with this library. And although in the screenshot it shows this glitching, I'm not sure why it has this jumbled mess here. But as soon as I disabled the shadows of the fonts, it worked fine without a problem on both the emulator and the hardware itself. Okay, so a quick demo. I'm just going to use a website that has TOTP for login. So it asks me for the code now, and we can see here. Okay, so it worked as expected. Now, for future work, I posted this on Reddit, and there's a neat idea from someone which replied to me in the comments that is importing the QR code directly using the PSP's camera, not having to go through to export the file, then save the file on the memory stick. Now, I don't have either of these cameras here, the two models, but I noticed they have two different resolutions. The old one has 1.3 megapixels, and the newer one actually has a lower resolution here at 0.3 megapixels. Now, this depends on two things, which the first being the resolution and also how well it captures still images, how blurry the result is. This is going to influence whether we need pre-processing and things like image correction, perspective correction, because the decoder algorithm depends on distinguishing the corners and the dots. As the image gets progressively blurrier, then the algorithm probably won't work as well. The second thing is finding a decoder library in C or C++ that can be compiled and lightweight enough to run on the PSP's hardware. This zebra crossing library that seems to work with the PSP SDK toolchain, but I haven't done extensive testing at this point. Okay, to wrap up, thank you again for listening to my talk. I've been Arthur. Hopefully this tool is of use to someone out there. Link to GitHub is right here, and there's instructions for you to try it on your own PSP. My email is here as well. I'm also on Twitter at rclearn, and I'd love to hear your thoughts and feedback. Peace.